We humans have been searching for life, or at least traces of life, on faraway exoplanets and other objects. But there seems to be a possibility that life, or at least the bacterial life, can exist on one of the moons in our solar system. And this is the topic we're going to discuss with Fabian Klenner. And the partner of our interview series about science and technologies is Team Telecom Armenia. So, Mr. Klenner, why do we think that one of Saturn's moons is able to support life? I'm talking about Enceladus, if I'm pronouncing it correctly.
Yes, you do. So Saturn's moon, Enceladus, is extremely interesting for the search for life, and this is because we know from one of the past NASA missions that was in the Saturn system and did some measurements, that was the so-called Cassini mission, that we know that this tiny moon, Enceladus, has a global liquid water ocean. So you have to imagine that there's liquid water so far away from the sun, but this water is not at the surface, it is in the subsurface under a thick ice crust. So there's liquid water far away from the sun on a moon around Saturn. And if you look at Earth, so here our own planet, wherever there's liquid water, there's life. So if we find liquid water in the solar system or maybe somewhere else one day, then we are very curious to find out if there could be life or not. And then also this NASA mission collected tons of data, and we analyzed a bit of that already, and we found that there are several other very interesting things. So we found this liquid water is very salty. It has organic compounds, so carbon-based compounds. This moon has plenty of energy. So there are the ingredients for life, as we know it from Earth, present on a moon around Saturn. And this makes it so incredibly interesting. So I really hope that NASA or another space agency will soon send a mission there to really find out if there could be life or not.
Is that just an assumption, or are we really sure that there is liquid water under that thick ice layer?
We know that for sure. So when the Cassini mission was built, the engineers did not think that this moon is so extremely interesting, and they have sent a spacecraft towards Saturn to investigate the planet and the rings and the moons. And then we approached Saturn, and the Cassini mission came closer. The Cassini spacecraft came closer to Enceladus, and it found a kind of volcano ejecting material into space. That was a spectacular finding. So there was just in space this tiny moon flying around, and stuff is coming out the moon. And then Cassini came closer, and it turned out from several measurements, from several instruments, that the material comes from liquid water under the ice crust. And then there are also other measurements, not only from the analysis of that material, but also from other instruments when we just fly by the moon, and then you can find out that you can explain the profiles of the moons in the data only by having liquid water under an ice crust. So we know that for sure, I would say, that there is a liquid water ocean on the moon, and we are very sure that the material that is ejected into space comes from this water ocean. So whenever a spacecraft is there and analyzes the ejected material, we can get information from stuff that is ongoing in the interior of the moon. And this is so cool. So we do not necessarily need to land on the moon or dig into the ice crust or whatever. We just analyze the material that is ejected in front of a spacecraft, and we get information from the ocean.
Don't we need to send another spacecraft there to take samples, bring them back to Earth, to analyze them, and to make sure that it's really liquid water?
That would be awesome to have a space mission going there, collecting material and bringing it back. But this is technically currently extremely challenging. So what is much easier is sending a spacecraft there, analyzing the material in situ. That means just when the spacecraft is very close to the moon, when the spacecraft is there, doing the analysis from the material that is ejected into space, because we know it comes from the ocean. So this is a very easy thing to do. The next step is what other scientists are also thinking about, to build a spacecraft to land on Enceladus, so to really land there and then melt through the ice crust or dig into through the ice crust and somehow try to reach the ocean, or just analyzing the ice crust itself. And there are also other missions that try to send a robot to the moon that then finds its way through channels into the ocean, and there are so interesting things ongoing. So I'm really hoping that something of this will fly in the future.
How thick is that ice layer? Do we have any information about that?
Yeah, so in the region where the cryovolcanoes are, where the stuff is ejected into space, we think that the ice layer is relatively thin, and with thin I mean 5 kilometers, maybe 10, between 5 and 10 kilometers. This is really thin. And then if you
That's
go,
the
yeah, and then if you go to other regions in the moon, it extends to 30, 40, maybe even 50 kilometers. So this is really thick then. But in the South Polar region, where the volcanoes are, where the eruption happens, there the ice crust is relatively thin.
Do we have any specific information about what that water consists of? Is that H2O?
Yes, it is water as we know it from Earth. It is H2O. It is liquid water, and we also know that in the liquid water there is plenty of salts. So and this is strong evidence for the ocean is interacting with a rocky core, which is under the ocean, which is below the ocean. So there's a rocky core, there's the ocean, and this is interacting. So salts and other stuff that is in the other compounds that are in the core can leach into the ocean and then get available for whatever may be in the ocean in terms of life, or maybe not, we don't know that. But so there is plenty of salts in the ocean. And we also know that there is a variety of organic compounds, so these carbon-based compounds in the ocean. So there are very small, tiny carbon-based compounds. There are also more complex carbon-based compounds. So we all know that from measurements that were made by the Cassini spacecraft when the Cassini spacecraft analyzed this material that was ejected into space. Yeah, so we have salts, we have organic chemistry, and then there are also gases that are coming out that are probably exsolved somehow from the ocean water or from freezing ice grains forming over the ocean layer. So there's plenty of interesting things ongoing.
So there is a huge chance that some type of bacterial life can really exist in that liquid water.
Yeah, of course, we don't really know that. And for example, we published a study last month in which we were focusing on life as we know it from Earth, and we were trying to figure out if we can, in theory, detect that. And this works pretty well. That was the bottom line of our story. But of course, we focus on life as we know it from Earth, which requires liquid water, organic chemistry, energy, chemical disequilibria. But these things appear to be present on Enceladus. So it's basically, in my opinion, it is a good approach to look for life as we know it on an ocean moon like Enceladus. Yeah, and because you were asking about the conditions in the ocean and how life may adapt to it. So, of course, the ocean water is relatively cold. We think so it's liquid water, but it's extremely cold. So maybe around 0 degrees C, 0 degrees Celsius, 0 degrees centigrade, something like that. And so if life is really in the ocean in this water column, it must adapt to cold temperatures. So, but what we also know is from this interaction that the ocean has, so the ocean and then the rocky core, this interaction, there it's probably relatively hot.
If life really does exist in the water of Enceladus, and if we prove this, what will it mean for us and for science?
This would be incredibly interesting. Let's assume we really find life on Enceladus. Then this life would certainly have evolved completely independent of life on Earth. So there are two origins of life in the same solar system. So basically in the same neighborhood. And if this is true, if this is confirmed, so then I think why shouldn't we have many other life forms out in the universe where we haven't looked or where we have not the technology to find it out yet? So if there's really life, this would be a game changer in the way of thinking of people about the origin of life and the abundance of life in the universe.
Are there any other planets or moons in our solar system that also have liquid water?
Yes, so there is another moon around Jupiter, which is extremely interesting because it also has a global water ocean that is interacting with a rocky core. So the moon's name is Europa. And also here, there's, as I said, liquid water. There is some organic chemistry ongoing. There's plenty of energy also. So we have also the ingredients for life. And the cool thing with this moon is that NASA has decided to send a spacecraft there very soon. So launch is scheduled in October this year. And the mission will arrive at Europa in April 2030 and do then plenty of measurements to figure out if this moon is able to support life or not. And then also there are other objects. There are other moons of Jupiter that have liquid water. There is another moon of Saturn that's called Titan, which is also very interesting for the search for life because there's so much organic chemistry on the moon and there is a water ocean under an ice crust also. So there are several objects in the solar system with liquid water, but the two most interesting or the two most promising for life are probably Enceladus and Europa because they have these oceans which are interacting with a rocky core, and the rocky core is a source of heat and interesting chemistry and good elements.
Is Enceladus totally covered with water? Like it consists of an ocean and an ice layer, right?
Yeah, so basically the uppermost, it depends, the uppermost 20, 30, 50 kilometers, it depends where exactly you look at the moon, are water. And there, the very upper layer is ice, water ice. And then under the ice, you have liquid water. So there is, this moon is basically, it's an ice ball flying through space. And also the water on the top layer, so the water ice is extremely clean. So it's a very Enceladus is a very, very bright object. It's extremely white and bright because it reflects nearly all the sunlight it receives. So the water that is coming out and that is continuously coming out the moons, and then much of these icy grains are then falling on the moon again, and this is very clean water, most of it.
How exactly are you and your colleagues studying Enceladus? Can you tell us more about your research?
So, coming back to the study that we published last month, so I was mentioning this plume, this volcano that is ejecting material into space. And we know that this material consists of gas and ice grains. And all of this comes from the ocean. And on the Cassini mission, on the Cassini spacecraft, there was an instrument that was designed to analyze these ice grains individually. So, and we know so much of the information we have from the interior of the moon, we know from this ice grain analysis. So, for example, what the ocean consists of, that there are salts and these carbon-based compounds. We know that from ice grain analysis. And then we were really curious to basically test the limits of these instruments. If we can use the same instruments that anyway analyze ice grains, if we can use them to find maybe life, or to find very complex organic chemistry, or maybe any signs of life. And then we did plenty of experiments in the past years, but the highlight was really now the study that was published last month, where we have tested bacterial cells, and we have simulated this case in the lab, where you have a bacterial cell in an ice grain, and that is then detected by such an instrument in space. And we can, with our lab setup, that was in Berlin, in Germany, with that setup, we could create data which is very, very well comparable to the data that these instruments from space generate. And in the data in the lab, we find signatures that are characteristic of the bacterial cells. And this means if an instrument in space would indeed detect a bacterial cell, which is incorporated in an ice grain, then we expect that it would deliver very similar data as the data that we got in space. So my work is mostly about doing lab experiments. And since I started here at the University of Washington, where I'm now for a year already, I also started to do some simple modeling work. And I basically try to better understand this whole ice grain thing on Enceladus and other icy moons. So I'm also particularly interested how these ice grains actually form, because we don't really understand that. We never looked onto the water, and we never observed ice grains forming from the water on Enceladus, of course not. And I really want to understand this, and this then also helps to understand if bacterial cells, if they are indeed in the ocean, if they could be incorporated into these ice grains and ejected into space.
What exactly is the problem with understanding and studying those ice grains?
Yeah, we just don't know much about it. We know that these grains somehow form and they get ejected into space, but there are several mysteries about it. And for example, one thing that is not well understood is how fast these grains actually freeze from the ocean water. Um, you would expect Enceladus is extremely cold, and maybe they freeze then relatively fast, but also there are scientists who rather think maybe it's not that fast, because just above the ocean there's not a pure vacuum, and there are many of interesting things that are just not well understood. Another thing is, which is not understood very well, is, for example, the phase state of these grains. This means if these grains have crystalline structures, or if they don't have crystalline structures, and all these things. There are so many things that are not well understood, but understanding this will help us to get a better understanding of the moon in general, how this works, and to better understand if life or complex chemistry could be preserved in these grains, and we could really find it. And if that's the case, we can send a lander there and analyzing the material that is ejected, that is ejected from the plumes and then falling back on the moon, and then we can analyze it, and maybe we find something very interesting. Yeah, and also this work is also relevant to other icy moons like Europa, this moon that I mentioned.
How are you going to continue your research? Like, where is it going?
Yeah, I try to better understand this, what we were talking about, and then I want to apply it to other icy moons like Europa or other objects in the solar system where we have liquid water and where we can form ice grains from liquid water. There's also a dwarf planet, Ceres, for example, which probably has some liquid water under the surface, and ice grains can form. So I want to do that. And then also I will think about incorporating other compounds into my experiments in the lab, because for now I'm focusing on these Enceladus salt systems, and yeah.
What exactly do we need to do to finally answer the question if there is life on Enceladus?
Here again, I can refer to our study because there actually we have demonstrated that there are instruments that can detect life if it is there, that can detect bacterial cells if they are there, and these instruments already exist. So what we have to do is build such an instrument that is using a technique that is called mass spectrometry, send it to Enceladus, fly through the plume, and analyze these ice grains again individually, but with very high instrumental capabilities. So analyze these grains individually, and then you have to analyze quite a few thousand of them to get a cell, to find a cell if it is there, probably. But we have demonstrated in our study that this is definitely possible with instruments that are already in the pipeline. So they are being built, but someone has to decide to send a spacecraft there and do that.
Hasn't anyone decided to do that yet?
No, so we know that so 2 years ago, NASA has announced that so NASA is every couple of years they are doing a priority list of targets in the solar system that they want to explore. And Enceladus has the second highest priority on this list, which is really great because whenever NASA is picking their next big missions, they will definitely think about Enceladus and may do so or not. But also the European Space Agency announced, I think it was 3 weeks ago, maybe 4 weeks ago, they just announced that Enceladus has the top priority whenever the European Space Agency will select their next big mission. So I'm very optimistic that an Enceladus mission will happen in my lifetime. So we are talking about things that will happen in, let's say, 20 years or so.
Which mission is the top priority for NASA at the moment?
It's an Uranus mission.
Why?
Yeah. First of all, we don't know a lot about Uranus. So we haven't had a spacecraft there that was dedicated to investigate the Uranus system. So we just don't know a lot about it. Uranus itself has many moons. So we have no idea, but maybe there is another moon with liquid water or maybe jets that are ejecting something into space. We just don't know that. And also Uranus has a beautiful ring system. So I think NASA is extremely curious to find something out about Uranus. And yeah, so Uranus is basically an icy gas ball that is flying through space very far away from the sun. And we never had a mission to find something out about such an object. So this is also very exciting.
Uranus really does sound exciting, but Saturn also has more than 140 moons, if I'm not mistaken, and we still don't know a lot about them too, right?
This is true, yeah. So we don't know a lot about most of these moons, but also most of these moons are relatively tiny, so they are not expected to have liquid water or anything that is obviously very interesting for the search for life, for example. So Enceladus is certainly one of the most exciting, if not the most exciting moon of Saturn. And then there's Titan, which is very interesting. And there are some other interesting icy moons that may have liquid water or not. There's, for example, Mimas. That's another moon. So where just recently scientists found something that gives us some evidence for liquid water on that moon, for liquid water ocean on that moon. So yes, of course, you're right. So we don't know a lot about many of these moons, but at least there was already the Cassini mission, and we know something about it. And yeah.
Does the moon have to be of a certain size to be able to support liquid water?
Yes. So if the moon is too small, it will just freeze, and it's maybe a dirty ice ball, and you will not have, you cannot maintain liquid water there. So you need a certain size, certainly, to maintain a liquid water ocean. And then you need a good distance from your planet, like Enceladus has, or also Europa has from Jupiter. So because the distance from the planet, then also due to it's called tidal heating, because the moon is orbiting the planet, and sometimes it's a bit closer to the planet, sometimes it's a bit more far away. And due to the changes in these forces, you can create a lot of energy in the moon, which maintains the liquid water then.
Do we have any information about the exact size that the moon has to be able to have liquid water?
That's a very, very hard question. So Enceladus is about 500 kilometers in diameter, so it's not even so big. Europa is a bit bigger. It is approximately the size of our moon here, but I cannot tell you an exact number, an exact size that we need to have a liquid water ocean.